Here we are going to discuss number 9. It reads, the aim is to test the hypothesis that there was a significant variation in the number of applicants for Math 121 between the years 2023 to 2024. So you are given the task of testing this hypothesis. The hypothesis here is there was a significant variation in the number of applicants. So this is a chi-square test for variation. Here you've got the chi-square critical value, which is 7.815, and the formula to calculate the chi-square test statistic. So because this is a chi-square test for variation, the null will state that there was no significant variation in the number of applicants for Math 121 between the years 2023 to 2024. So the null is always the conservative one, okay? There's no factor affecting, all right? There's no significant variation in the number of applicants. That would be for the chi-square test for variation. And the alternative will be saying that there is a significant variation. So for the chi-square test for randomness, the null will say no factor affected. For the chi-square test for variation, the null will always say there is no significant variation, okay, between the two times. And the alternative will say that there is a significant variation. So now we've got to process the data that was collected for the years 2023 and 2024. So here's the table with the data that was processed. The first column will have the observed values. That's what was observed in the most recent years, 2024, and the more ancient years, 2023, that's what was expected. So the expected values will be in the previous years, and the most recent years will be the observed values. There is no need to calculate the expected values because here they are already, which will be the more ancient years, okay? That's what is expected, and that's what was observed in 2024. So now we can proceed to calculate the chi-square contributions, 4 of them, O minus A all squared divided by 30 minus 26 all squared divided by 26, right up to 16 minus 30 all squared divided by 30. These will add it up to calculate the chi-square test statistic. Now, as we all know, the distribution curve for the chi-square test is a curve that is skewed towards the right. The critical region or the rejection region will be on the right. The critical value will be on the critical point, which will be a positive number on the right side of the curve. And now we calculate a chi-square test statistic of 9.809, which is more than 7. 9 is more than 7. So the chi-square test statistic will land in the critical region, as you can clearly see right there. So we have to reject the null hypothesis because the chi-square test statistic is in the critical region. And we all know by now, either you reject the null or you do not reject the null hypothesis. So you need to, by now you should know that already. Take out your pen, your pencil, your calculator, your paper, and to do this, actually perform the test using this video as a tool to help you prepare for your evaluation. And also to learn how to perform this test for future research that you may be involved in. As we can clearly see by now, we have rejected the null hypothesis because the test statistic is in the critical region. So here it is stated, reject the null hypothesis. And the conclusion is, based on the data, there was a significant variation in the number of applicants for Math 121 between the years 2023 to 2024. Because if the null hypothesis is rejected, the alternative hypothesis will be the conclusion. And here it is stated that there was a significant variation between the 2 years based on the data. So just to summarize the step for any hypothesis test, critical value approach, you state your pair of hypotheses, you sketch your curve, you place the critical value on the critical point, then you calculate your test statistic to see where it lands, if it lands in the rejection region or not. If it lands in the rejection region, you reject the null. If it does not land in the rejection region, you do not reject the null. And then you conclude. If the null is rejected, then the alternative is the conclusion. And if the null was not rejected, then the null will be the conclusion. So in this case, the null was rejected because the test statistic is in the rejection region. So the alternative statement was the conclusion. So please do this over with the guidance of the video and other resources that are available to you.